All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is multiplying radical expressions. So, what they want us to do is not just to multiply, but also to simplify. So, when they say multiplying radical, and then of course, it says simplify right here as well, right? So there's actually two things they want us to do. They want us to multiply and then simplify. So that's pretty much how the steps are going to work. You don't want to simplify first and then multiply because there might be more simplifying to do after because it might have more things afterwards. So definitely do them in the order that you see them in the worksheet, which I don't even know if they intended it to be that way. But multiply first and then simplify. So if we're looking at the first one here, we would multiply the 12 and the 6. We can't multiply the 3 with the 12 or the 6 because it's not inside the radical. It doesn't go with the other numbers. It's like how the radicals are like, different. It's like different people. They're radical people. So they only multiply by each other because radicals stick to each other and they're a tight-knit group. So anyways, the radical numbers, those are going to multiply. The regular numbers are going to hang out with the other regular numbers, right? The regular people with the regular people. Radicals hang out with radicals. So 12 times 6, okay. What's 12 times 6? Okay. Well, that's going to be, what, 72? Okay. Still a square root. And I still have a 3 out here. Okay, so then, what we want to do is we want to simplify the radical. Well, I know that it's 12 times 6. I just got that. I don't need to do that necessarily. I need the largest square number that can come out of 72. So if you can't think of the largest square number, just think of square numbers to come out. If you've been watching videos that I've done on this topic before, I do a method that's called the square factor tree. So let me show you an example. So let's say we'll do the example with the 72 over here. Right? So square factor tree. What I do is I say, okay, well, does it divide by 4? Yeah. Yeah, it divides by 4. Take half, 36. Take half again, 18. Okay. Does 18 divide by 4? No. Okay. So then I move on to the next square. Well, the next square number is going to be 9. So doing this method requires you to know your square numbers, but there's not that many that you really need to know to do this method. And in order to divide them, it's pretty easy to divide them too, even without a calculator, because let's say I want to divide by 4. We'll just take half of 72. It's 36. 36 is even. So yeah, it's going to divide by 2 again, which means it divides by 4, which means 72 divides by 4. That's how I knew. And then you just take half twice. 18 doesn't divide by 4, because if I take half, I get 9. 9 is odd. But, hey, 9, speaking of, 9 is another number that is a square number, so I can take out 9, and I have 2 left over. What I have left over, then, is pretty obviously, like, just my leftovers. If the number was big enough, you would keep going. You'd be like, okay, well, does it divide by 25? Does it divide by 49? If I have like a 3 or 4 digit number left over, it probably is going to divide by some other square number, right? And then you can also check for 9 again. But 2 is smaller than 4, and we already tried 4 and 9. So 2 is definitely, there's nothing going on with the 2, right? Then what we do is we say, okay, well, square root, square root, square root, right? Because 18, it's not 18 anymore. It's 9 times 2, so the 18 went away as well, right? And then that's going to be 2, 3, and the root 2 stays because I can't take the square root of 2. And then that would be 6 root 2. Okay, so that's the factor tree, the square, I guess I would call it the square factor tree method, right? So the square factor tree method says do it like this. I'm going to show you another way that is probably the fastest way, and that is to just think about all of its initial factors, and you don't have to necessarily do this in your head, And you wouldn't even start with 1 because if you know that 72 is not a square number, you wouldn't need to start with 1. But just for an example, we go through all the factors. So 1 and 72, 72 isn't a square. 2 times 36 is 72, right? Well, 36 is a square number. So that's it. That's the largest square number. So what you do is you just cycle through all of the numbers that divide by 72 and go from smallest to biggest because the other number is going to be the bigger number. And then that's how you get the thing to simplify. You stop at the biggest square number. Now, in order to do it this way, you have to know more squares. So if you're not real good with your squares numbers, if you don't have a lot of them memorized yet, then this method might not be the best for you. If you only know, let's say, 4, 9, and 25, then probably want to stick with the earlier method, right, which would be the square factor tree method. Right? But the fastest way to do it is to know all your squares. So let's get back to it. This would be 6 root 2. And then I've got that 3 there still. It has to get timesed by the 6. All right, be careful with that. It's always going to be timesing, unless you see a plus. If you don't see a plus, don't assume plus. Assume times. Right? When you don't see a sign, you assume times. Always. All right, so 18 root 2 is the final answer. Right? 6 times 3. All right, and that's pretty much it. That's what we do. We multiply and then we simplify. So multiply 5 times 10 is 50. So that is 1 times 50 is not a square root though, right? So then 2 and 25. Oh, hey, there we go. 25 is a square number. Right? So then I'm going to flip the order because it looks nicer. And you don't have to put a little dot. You'd have to put a little dot if you're going to do it the other way. Actually, let me write it this way and show you what I mean. So if I do root 2 times 5, I'd have to put a dot there. Otherwise, it looks like I just sloppily wrote the square root of 25 if there's no dot. But, so that's actually fine, unless your teacher's really picky. Or, the better option would be to put the 5 first. When you put a number right before some sort of symbol, you assume times. When you put a number after another number, you can assume times, but sometimes that's just part of the number. Like 2, 5 could mean 2 times 5, or it could mean 25. So that's why it's better to put it before the sign, because you wouldn't say that's the square root of 52 if you put the 5 first, right? Because there's like obviously something in between the 5 and the 2 now, right? So just be careful with that. Okay, so number 3, 6 times 6 is 36. Oh, look, that already has a square root. Boom, we're done. Okay, moving on. So then 5 times 20 is 100. I'm going to bring the negative 4 out to the left here. 5 times 20, 100. The square root of 100 is 10. So then it's negative 4 times 10, which is negative 40. Negative times a positive is a negative. Okay, let's switch colors here. Switch to a nice green color. So now we have number 5. Now we have 2 negatives. Negative and a negative make a positive. Everything's getting multiplied here, so it just becomes positive. So then I have 15 times 3, which is 45. And then 45 is not a square number. Doesn't go into 2. Does go into 3. 15 times. 4, no. 5, yes. 5 times 9. 5 times 9. There we go. 5, 9. Right? So now that would be 4 times 3. I'm going to bring the 9 out front. 4 times 3 times the square root of 5. So that's 12 square root of 5. And there we go. All right, number 6. Everything is under the parentheses now, so we just multiply them both. That's 400 x cubed. There is a square root of 400. We literally just multiplied it. 20 times 20. Well, if we multiply 20 and 20, that's the square root of 400 is 20. And then there's another thing. So with letters are a little tricky. We haven't really talked about letters yet. The trick to letters, if you're doing a square root, and I actually haven't checked yet. But yeah, they all look like square roots. So if it's cube root, it would be a different thing. If it was a cube root, you would want to divide by 3. But the trick to figuring out how many powers of the letter stay in and how many powers go out, it's a little bit different, but it's actually kind of the same. But it'll look very different, so that's why I want to show you. What you do is you take the power and you divide the power by 2 for square roots, right? So if you're going to simplify, this is what you do. You take the power and divide by 2. So power divided by 2, right? And that's for square roots, Power divided by 2 for square roots, okay? So then, from here, we want to divide it all out. And you want to do that thing where you have the R for remainder. So we stop at the remainder. Stop at the remainder. Okay. And if you're taking notes on this, you would put like write it all out because you'll look at it later and be like, "What's capital R?" I just kind of ran out of space and I didn't want to put that all on a separate line. Stop at the remainder. And then basically here's what happens. So the amount of times that it divides evenly, so the top number is how many powers can come out. Is the amount of powers that come out. Is the power that comes out of the square root, right? And then the remainder is the power that stays in. Power that stays in. In what? In the radical. Right? And so the only difference between this and if you had like a cube root, so let's say you're doing a worksheet that's similar to this, but it's harder and it's got cube roots in it. The only difference really would be in step 1. You would just do the power divided by 3 for a cube root, or the power divided by 4 for a fourth root, and all of that kind of stuff. So that's really the only difference. So here's what happens. If I take 3 and I divide it by 2, let me show you. Goes in once. 1 remainder 1. Okay? So the first one is the powers that can come out. All right? The 20 came out because it's the square root of 400. And then there's a remainder. So 1x has to stay in. 1 power of x has to stay inside the square root. Okay? Letters are a little bit of a different ballgame, so you really got to switch gears on those. All right, next one. So 15 times 10, that's 150. In 2, in 3, when you do power times the power, you add. So in 5. Remember, everything's still under the square root. Now, 150 divides by 25. Right? So this is an even faster way, is to just think of whatever the highest number is that might divide by it. It's even faster than the method I showed you earlier. And it basically is not, it's not really a method, it's more of like a intuitive approach. You just kind of like, you just do it. You just think of the number. And that just comes with practice, right? So that and that. And then 5 divided by 2 goes in twice. Then I have a remainder of 1. So I have 2 powers of in that can come out, and 1 stays in. So then I have altogether here, that'd be square root of 25 is 5 in squared. And then I put the 6 and the in back together. They're both square roots. And if they're both square roots, then I can put them back under the same radical. And there we go. Right? So I multiplied and then I simplified. Simplify is definitely the longer of the 2 steps. But hey, it's 2 steps. It's a 2-step process. No big deal, right? Okay, 18 times 3. What's 18 times? I'm ignoring the 4, notice, right? Because there's not really anything to do with that. That's outside the radical. 18 times 3, what's that? Well, it's, oh gosh, what is that, 54? Yeah, 54. And then A4. was like doubting myself for a second there. Yeah. And then 54, I know that's 9. Yeah, that works. 9 times 6. So 9 and 6. Boom, boom. And then A4, well, 4 divided by 2 is exactly 2. It goes in evenly. So that would be 2 powers of A that can come out. Okay, and then the square root of 9 is 3. I'm running out of space here, so I have to start to speed up a little bit. And I usually speed up a little bit as we go along anyways. But we'd have 4 times 3 is 12, and I have 12a squared square root of 6. 12a squared times the square root of 6. Okay, so now moving on, let's go ahead and change colors too while we're at it. Let's change to a nice, like a gold color here. So then I have 7 and 7 make 49. R3, R2 is R5. And I have 3 times 6 is 18. All right, so I'm going to put that out front. The square root of 49 is 7. 7 times 7. Yeah, so it's just square root of 49 is 7. So that's going to be 7 times the 18. Oh, I don't know what that is off the top of my head. Let's multiply that out over here. So 8 times 7 is 56. And then that's 7 to 126. Okay, that should be good. 6, 7, 8, 9. Yeah, okay. So then that's 126. Sorry, my mental math is a little weak today. It comes and goes, you know, you're not always on your A game. So R5, okay, 5 divided by 2 goes in twice, so 2 powers of R, with 1 remainder of R left over. So there's my final answer. All right, next one. So 28 times 7. Okay, 28 times 7, what's that going to be? Well, that's 49, 98, 196. And then x4, power times a power, you add the powers. Okay, so all of that is still under the square root. That I can see here. It looks like it is. I don't know. Let's see. I can erase that a little bit right there. Yeah. Okay. So I wonder if I can I control Z that? Oh no, I can't. Okay. Well, whatever. That's the final answer for that one. So just had to make sure it was covering the x, because sometimes it doesn't, and then the x would be like separate. So okay. So then all of that is under the radical. Negative 4 out here. And actually, 196 has a square root. It's 14. So this is going to be negative 4 times 14 times x squared. So then that's going to be 56, negative 56, x squared. Everything came out that time. That was nice. Okay, so then here we've got, we're going to have to distribute. So here we are multiplying, but distributing is a little bit different than regular multiplying because we're multiplying several things. So we multiply the square root of 3 by the 5. Nothing happens there because 1 is a regular number, 1's a radical number, right? Radicals and regular people. So radical 3, square root of 3 times square root of 3 would be the square root of 9, which is 3. Okay, square root of 3 is the square root of 3 squared when you multiply them. So it cancels. Or you can say square root of 3, you multiply them, you get the square root of 9, 3 times 3, and the square root of 9 is 3. So however you want to think about it is fine. Either one of those methods is fine, but you definitely don't want to be writing out the square root of 9 as an in-between step. You definitely want to get to where you're just writing out the number there. And that's about all we can do, actually, because can't simplify anything else. So we're done. That was it. Easy work. Okay, so then I have 2 times the square root of 30 plus, because that was root 5, root 6, they can multiply, plus 2 times 2 is 4 root 5. Okay, so the root 5, that's definitely not simplifying. What about root 30? Well, it divides by 2. 215, no. It divides by 3. 3 and 10, no. 5 and 6, no. There's no square numbers. It has a lot of factors, but it doesn't have any factors that go in more than once. It doesn't have any square factors. So we're actually done. It's as far as we can go. All right. I kind of want to go ahead and do one more set here with the same color, because it's just it's not really hitting a lot of work just yet. So then this is going to be negative 3 root 3, oh, sorry. I thought that was a root number. Erase that. So root 3 times 2 is -6. Sorry, negative 3 times 2 is -6. Then you have the square root of 3 left over. All right. Minus, because I'm about to multiply a negative and a positive. -3 root 3 times -6. That's going to be -3. 3 times 6 is 18. Now that simplifies, because 18 is 9 times 2. Right? So then altogether, this is going to be -6 root 3. That's going to be the square root of 9, which is 3, but times by the 3 that's already there is 9 root 2. Right? So that square root of 9 is 3. The square root of 9 is 3 times that 3 gives us 9. Okay? All right, here. So we have root 3, root 10, so that's going to be the square root of 30. And then here I have the square root of 18 again. Square root of 30, we already know that's not going to simplify, but the square root of 18 we know does. 9 and 2. So square root of 5, -5 root 30. I can't talk today. Plus 3 root 2. And there we go for that. That's it for that one, actually. Okay, now let's switch to another color. That was like a yellow, so we go to an orange next. Not quite a yellow, but yellow's kind of hard to see, so I usually just do like a gold. So it's already kind of orangey-ish. Okay, so now at this point, we're doing pretty much all the same stuff. It just, they try to make it look crazier as we go here, but you just got to take it one step at a time. Multiply all the regular numbers and the radical numbers separate. So -2, -3, that's 6. Root 15, root 3, that's root 45. Okay, let's do it again. -2, positive 3, root 15, root 5. And what would that be? Is that 75? Yeah, it's 75. Okay, so both of these simplify, actually, because 45 is 9 times 5. 75 is 25 times 3. And notice I'm putting the big square number first because that actually looks nicer as we go along. So eventually you want to get around to doing it that way. So then we have 6 times 3 is 18, root 5, minus square root of 25 is 5, times 6 is 30, root 3. And that's it for that one. Okay, cool. So then here, same thing again. 5 times 4, one step at a time. 5 times 4, that's 20. Root 42x. And then 5 times 4 is 20. Root 7x. And notice I'm putting a little, like a little backsplash, a little wall on the back side of that radical. That doesn't mean anything special. It's just a way to show that, like, hey, the radical ends right here. Because sometimes if you don't put the radical over far enough, then it might look like the x that's inside the radical is separate from the radical. It's not actually underneath the radical. So you put a little like halfway closed garage door kind of thing on that house to show that, hey, the x is inside of here, so don't get it messed up. So that's why I put that there. It's not anything special. It's just a way to help me, to show me, like, oh, hey, like, that's part of that. Okay. Oh, by the way, I was talking and I forgot to multiply the right stuff here as I was talking. So 5 times 4 is 20. Then we have 42 times 7. Yikes. Let's see, 42 times 7. 14. That's 28, 29. Okay, so 294. That's 294. And then there's two x's, so it's 2x's. 294. X squared. Whew, okay, a little harder there. Okay, so 42 is 6 times 7. What else is it? It's 2 times 21. It's 3 times 14. I don't think there's any square numbers in there. If we did a factor tree, it would just be like a 2, a 3, and a 7. Oh, no, wait. No, 4? No, it's just a 2. 2, 3, and 7. I think that's it. Yeah. So that doesn't simplify, actually. But 294, there's no way that doesn't simplify, right? And actually, if you look at 42, 42 is 7 times 6, and that's a 7, so I know that's going to be 49 times 6. It's a little shortcut. And then that's an x squared, so an x is going to come out of that. So this would be 20 square root of 42x. 49, so square root of 49 is 7. 7 times 20 is 140. Right? 2 times 7, 14, add a 0. And then an x. An x comes out. And then a root 6. Ooh. Hoo, hoo, hoo. I got pretty gnarly there. Okay, moving on. Root 14x times 3. Okay, well, that's just 3 root 14x minus root 28x squared. All right, so nothing happens with the first one, but with the second one, we've got a 4 and a 7. That's the largest thing, and then an x. So I'm just going to skip that middle step now, getting to the end of this worksheet, and we're going to need the space anyways for what's coming up next. Dun, dun, dun. So if I take the square root of 4, it's 2. So that's 2x root 7. Okay. And then here. Okay, so then we have 7n cubed root 6n plus 12 times 6. What is that? That's 72 root 72n, which simplifies 7n cubed root 6n plus, that's 36 times 2, so that's 6 root 2n. And we're done. All right, moving on to my least favorite color, red. So root 3 and 6, that's root 18v, and then a root 30v, right? And remember that 30 number, remember that 30 doesn't simplify, right? So don't even check it anymore. Just start to remember stuff. Root 18 does simplify. It's 9 times 2, so that's 3 root 2v plus the square root of 30v. And that's it for that. Then here we've got 5 root 21r plus, now 21 is 7 times 3, so this will simplify. It's going to be 7 for 1r. And I know that's going to divide by 49. It's going to be 49 times 3. So this is going to be 5 root 21r. And that's going to be that 7, so 7 root 3r. All right. I've only got a few more now at this point. So now we move on to, actually, you know what? No, we're not done with red. I want to be done with red. I don't like red. I don't know why I've never liked red. I just don't like red. Let me know if I'm weird in the comments. All right, so root 9, which I will simplify in a second, but this is actually a FOIL. We're actually foiling now. This is a full-out FOIL here. So first times the first, outer times the outer, inner times the inner, last times the last. Okay, and then that's actually going to be a square root of 9, which is a 3. So 3 times 2 is 6. Negative 10 minus 6 is negative 16 plus 12 root 3. And that's it. So I combined the first and the last thing, and then the middle terms. The middle terms usually always go together, but if the square roots simplify, then sometimes the outer terms will go together, the firsts and the lasts. Okay, first times the first, outer times the outer. That's a 5 root 5. Inner times the inner, last times the last. Okay, so that's going to be square root of 25 is 5. 5 times 4 is 20. Negative 10, negative 20, that's negative 30. And then we have 5 roots of 5 and 8 roots of 5, both positive, so we add them up and we get 13 roots of 5. Okay, so now we can go to the last color, which is purple, and I like purple. So purple's all right. Just everything except for red. And orange is not always, I don't know. But I like gold, and gold is like kind of an orangish color. So, anyways. Negative 2, positive 5. That's negative 10. Then that's positive 2 root 5. Then that's minus 3. Oh, no, not minus 3. I forgot about the other 5. Minus 15 root 5 plus 3 root 25. Okay. So then that's going to be root 25. So that's 5 times 3 is 15. 15 minus 10 is 5. 2 roots of 5 minus 15 roots of 5. So that's minus 13 roots of 5. And there's the answer. Now that looks a little bit like a 3, but that's actually a 5. Sometimes I write my 5s a little weird. Okay, next, moving on. Now we're going to go ahead and simplify as we go here. Root 5, that's 5. Root 5, root 3, that's root 15. Root 3, root 5, minus root 15. And then root 3, minus 3. These cancel. 5 minus 3 is 2. Whoa, that simplified really well. Well, actually, it simplified really well because those are conjugates. They're the exact same thing with the opposite sign in the middle. It's called a conjugate. So that's why that simplified so well. Okay, let's see. Ooh, man. Oh, this is way worse than 24. Oh, gosh. Okay, so that's going to be, there's two 2x's. So that's just going to be a 2x. 5 times 4 is 20. 20 times 2 is 40. That's a negative 40x. Whew. And that was just the first times the first. First times the outer times the outer. So that's going to be 5. So plus 5 x, because there's two x's being multiplied, and then there's a 2 and a 5 inside the parentheses, or inside the radicals that get multiplied as well. Okay, inner. So we have nothing simplifies there, so that's just minus 4 root 10x. Okay, notice that's different than having the x on the outside, so those are not like terms. And then on the last thing here, we've got plus, that's a root 5, so that's a 5 root x. And we're actually done. Nothing is a like term here. This has a root 10, this has a root 10x, this has a root x. None of those are exactly the same. They have to be exactly the same. If they're not like terms, and we're done. Right? So it looks ugly, but don't have to do as much work. So 25 wasn't actually that bad. It just looks ugly, right? There's the good, there's the bad, and there's the ugly. So negative 3, but then a 3, we've got two 3k's here, so that's 9k that comes out, 3k that comes out, and times by 3, so 9k. And then here we've just got positive 15 root 3k. Here we've got plus 4 root 3k. And here we've got minus 20. Well, now we've got some middle terms that go together. They're both root 3k's. Okay, so the first and the last don't go together, though, because that has a k, right? Like the standard not like terms kind of deal. Those are not like terms, so those don't go together. But these guys do. 15 plus 4 is 19, root 3k. And that's as far as we can go there. All right, we are on the last two. So if you like this stuff, if you like seeing worksheets worked out, or all the other kind of stuff that I have on the channel, you can check out. I have a free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. You can check that out on my website, myersmathematics.com, as well as a ton of other resources on there, like these sorts of worksheets and stuff like that. Like there's all that kind of stuff is going to be on there. So go check that out. Link in the description below. It's just my website link, which is myersmathematics.com. Okay, so the last two here, we just have 15, and then 5 and 3, so 5 root 3, 12 root 3, plus 4 times 3 is 12. Okay, and then 15 and 12, that's 27. 5 and 12, that's 17. And we're done. All right, last one. So 3 root 2 times root 2, that's a root 2, so that's a 2 times 3 is 6. 3 root 2 times 3 root 5r. None of the root stuff is going to simplify. 3 times 3 is 9. Square root of 10r, we still multiply it. It's just not going to simplify. It's not, nothing's going to come out. And then on the inside here, we've got plus the square root of 10. And then last times the last. The root 5s simplify a little bit, so that's a 5 that comes out. Times 3 is 15, minus 15 root r, and we have that same thing that happened on 25. None of this stuff goes together, so we're done. It's all not like terms. So that's it. That's actually the answer. So awesome. Fantastic. We're done. And if you liked it, you can go grab some more free stuff from other videos or my website. Email me if you're interested in tutoring. Like, subscribe, all that good stuff. And I will see you next when I see you next.